All right, thank you for your patience. You want to restrict their oxygen so they start producing ethanol. And then what you can do is you can let those yeast convert the remaining sugar to ethanol. So have them take all that sugar that's left and turn it into ethanol, or not. You can stop it earlier than that. You can then re-rack the culture, which means transferring a culture you have going to a new container to try and leave some sludge behind. You're trying to get the solids out of that, or you can not do that. You can then degas what you're brewed to try and get some of the bubbles out. If you don't like little bubbles in whatever it is you're making, like a wine, you don't always want bubbles in it, or you can not degas it. You can also, if it's not as sweet as you like, you can add some more sugar back, or either fermentable or not. And then you can bottle it. If you want bubbles, let's say you're making a beer and you want a lot of bubbles in it, I have a ginger beer I like, which is not exactly a beer, that I like to carbonate. In that case, I will bottle it and let it ferment some more to carbonate. Or if we're doing something like this, which is going to be a sweet red wine, I'm not going to bottle it and carbonate it. And then finally, what you can do is you can kill off the yeast to stop the fermentation, or not. Okay. As you might get the feeling from looking at this, there's a lot of options in what you do here in brewing, right? There are a lot of possible steps, and depending on what you consider quality of a brew, you may do one or more of these, depending on what outcome you'd like. So I'm going to start off with a demo here. What I have here is one that has started fermenting. I started this afternoon, and it's the same thing I'm going to put together here. Usually it's going a little more gangbusters. You can see a little bit of foam here, and what I have is an airlock, and these yeast are going to be producing carbon dioxide, and that's going to push carbon dioxide up through this part, and that's going to push the liquid up on this side, and you're going to see bubbling happening. Okay, I expect during my talk we will get a couple bubbles at least. Like I said, usually it's going a little more gangbusters. I think it's getting pretty hot in here, but I think in my office it wasn't quite so hot. But we should be able to see something going there. This that I'm going to start is not going to get quite that far. But part of why I wanted to show you how you might set up one of these things is I just want to give you a feeling how easy it is. All right, so what I'm going to do is start with 2 cups of sugar. And I'm just going to dump them out of the bag. I think there were 4 cups of sugar in this morning. But I think maybe you've got a feeling from all the or nots that it probably doesn't matter all that much that I get this exact. So I want to make a sweet red wine. Whoops. And so what goes into wine, by the way? Most wines. Yeast goes in. What else? Grapes. Grapes or grape juice. And so this is actually going to be a wine that comes from grape juice. I actually have a mojito wine that I make that's fancier than this, that has mint in it and lime juice, lime rinds. And that's a really nice wine as well, but it doesn't get together quite as fast, and it's a little more work to put together. Should have prepared some jokes, but it'll be okay. So I'm going to use some high quality grape juice here for it. And in fact, when I make this wine, I buy the cheapest stuff I can find on sale, which is usually this kind. So I'll be putting that in. And like I said, this is a cheap sweet wine I use at home. What I do with it is I generally don't drink it straight, although my wife does. I generally will make a sangria with it, or I'll mull it. You know what mulled wine is? Put mulling spices in it, and it's really nice that way. And as you can see right here, I'm about to use really high-scale fancy yeast in it. What does that say? Fast rising, rapid rise yeast, essentially. Okay, so this is what you use if you're making bread red yeast. And you'll see people have all sorts of opinions on what sorts of yeast you would put into wines. For this one, I don't care. For that mojito I told you about, I use champagne yeast. And champagne yeast is really very tolerant of alcohol. So I can get the champagne yeast will get that mojito wine up to about 20% alcohol. What's going to happen with these guys is they're going to tire out at about 8% alcohol. And in tiring out at about 8% alcohol, then they're going to leave a bunch of the sugar behind. And so what I like about that is I get sugar left over. I don't have to do anything special. They just stop. And then I can go on to use it how I like. Now, some people don't like particulates in their wine. They care if it's cloudy or not. I'm not as picky about that. So what I don't even bottle this. I pull it up out of my basement. I stick it in the fridge. And then I just let things kind of settle. And I pour off the top to make my sangria or to make my mulled wine. So what we've got here so far is, what have I put in so far? I put in some sugar, and I put in some yeast, and I'm putting in some grape juice, and that's going to kind of be it. So I'm going to have you sit with me for a little bit longer here while I get this kind of topped off. I want to get it right because I actually am going to, this one I started here and this one I'm starting right now, I'm going to bring these home and I'm going to put them in my basement, and I'm going to drink them in about a month or two. So this is a real brewing demonstration. And so if we look up here, so we started the yeast in a liquid containing fermentable sugar. So that's our regular table sugar that I used. Okay, nothing special there. There's also sugar in the yeast. Not the yeast, the grape juice. There's probably tiny bits of sugar in the yeast, but not a whole lot. And then the next step is I could oxygenate it to help them get started or not. And I'm actually going to oxygenate them. So I oxygenate them by shaking this back and forth. So those of you that have, you're all following chemistry courses, right? Full inversion, let the bubble get all the way to the top, let it go back again, okay? We're going to do this 60 times, or Conrad is. You don't know what back injury or anything, do you? No. Okay. All right. So Conrad's gonna invert that. Remember, all the way up, bubble all the way to the top. Yep. Okay. 60 times. Feel free to take a break if you want. And so then, while he's working on that, I'll continue on. So now I'd like to actually get into some of the chemistry here, and we're going to start off with the biochemistry of brewing and why you get ethanol out of this, which is our drinking alcohol. So in here we have sugar. Glucose is a sugar. That's sucrose. It'll get turned into glucose by the yeast, and the yeast will take that glucose and they will make it into ethanol and carbon dioxide. Okay, so the bubbles we get in this is carbon dioxide, and of course we're after the ethanol as well. So why do they do that? Because actually, I talked about the yeast getting tired out, right? This yeast is going to get tired out at about 8% ethanol, and like that champagne yeast gets tired out at 20. So why are they making something that, I say tired out, but essentially it keeps them from growing, right? And if you have too much, it can actually kill them. Well, this right here, here's our biochemistry. This is glycolysis here. Glucose gets turned into pyruvate. This is Khan Academy, by the way. So glucose gets turned into pyruvate. And in the process of making pyruvate, glucose is going to take this molecule right here. This is a coenzyme. It's called NAD+. And it's going to turn it into NADH. It's going to reduce it. Okay, so if you're an organic, you add hydrogens to things, that's reducing them. It's going to reduce it. Now, if more glycolysis is going to happen, I have to regenerate that NADH or NAD plus from NADH. And so the way that happens when you have a lot of oxygen around is the NADH comes over here to the electron transport chain. It dumps electrons in and becomes NAD plus. And then those electrons run down the electron transport chain until they get to the end. Here's the end. They get to the end and they get picked up by oxygen to make water. All right. The important part for the yeast, though, is that when they run out of oxygen, they run out of NAD plus because you're not regenerating this NAD plus here to go back into glycolysis. All right, so the yeast gets stopped if there isn't enough oxygen around. And so what they have to do is they have to make ethanol. And so that's what fermentation is. When we talk about making a product without oxygen, that is fermentation. And so the yeast run through glycolysis, they make that pyruvate, and then they'll take that pyruvate, they'll make some of that carbon dioxide from it, and they'll go make acetaldehyde and then take that to ethanol. And the process of going from acetaldehyde to ethanol uses 2-NADH to regenerate the NAD plus that can go back up here and help continue to fuel glycolysis. All right, so that's why the yeast are doing that. They don't want to, but this is their best way forward when there isn't oxygen around. Now, it turns out you do fermentation too, okay? For you, it's not, there's no oxygen around, but if you were working out really hard, if you're lifting a bunch of heavy weights, if you're running really hard, you are, as an animal, not designed to bring in enough oxygen for maximum exertion. So you don't bring in enough oxygen to run that electron transport chain I showed you before. And so what you need to do is regenerate your NADH or NAD plus so you can continue to run glycolysis. And instead of making ethanol, you make lactate or lactic acid. You've probably all heard about lactic acid before, right? When you work out hard, lactic acid is produced. And why it's produced is to regenerate this NAD plus so you can continue to run glycolysis a little bit longer, okay? You don't get much energy from glycolysis. You get a little more. You get most of your energy from oxygen and electron transport chain. But from an evolutionary point of view, that little extra bit of energy you might get from running glycolysis, a little bit more, might help you outrun a bear, okay? Or might help you run a little faster and catch an antelope. All right, so that's the reason why this happens. And it's apparently important enough that pretty much any animal has the enzyme that makes lactic acid in large amounts. Okay. So that's biochemistry, but there's a lot of general chemistry involved in brewing. And we'll talk about a little bit of it today. So one example of that, was that about 60?
Probably a lot more than that.
It is really oxygenated. Thank you. All right, so now I'm going to set this down. It's not going to start fast. If it was to start fast, I'd be in trouble because the yeast would make carbon dioxide and there'd be no place for that carbon dioxide to go. Okay, I'll show you some examples of that later in the presentation. So first off, let's talk about an example of something that's important or that gets used in brewing is specific gravity, which in Gen Chem, you've talked about that as density. So when we think about water, right, the density of water is 1, as you've probably either had to memorize or you've accidentally memorized because it was easy, right? And the density of water with sugar added, perhaps in this bottle, is going to be about 1.1 grams per milliliter. And that's about what you'd expect for a mead. Okay, so if you think about meads they're not beers exactly because they're not carbonated, but they're made with honey, right? Meads are made with honey. And it's a lot of honey. If you've ever made a mead before, you fill the bottle up about this far with honey, okay? And then you fill the rest of it up with water and whatever else you might want to do to flavor it. And those things are really, there's a lot of sugar in those, obviously. Now, the yeast are going to take that sugar, which made the water, the solution, more dense, right? And they're going to turn it into ethanol, which has a density of about 0.8 grams per milliliter. All right, so in doing that, in taking it down there, what's going to happen to the density of my solution? It's going to start off at 1.1, right? And as ethanol gets made, what's going to happen to it? Sugar's going to be used up, and what's going to happen to my density? It's going to decrease, right? Because I'm going to be getting more ethanol. Ethanol is going to become a larger fraction of that. And it turns out this is really useful, and lots of people brewing have studied it. And so we don't need to do something fancy like use a gas chromatograph to figure out how much ethanol is in our brew. it turns out that there are tables and all sorts of things on the internet for this that we can look up. So like we just talked about, the specific gravity or the density will decrease. And when the fermentation is complete, meaning all the sugar's been used, or stalled, meaning the yeast has, this yeast has gotten 8% ethanol and it's given up, okay, then that specific gravity will stop changing. Okay, so in 2 months, these guys will have stopped. They will no longer be taking sugar and turning them into alcohol. So a specific gravity of 1.0 indicates, in terms of the brewing community, indicates that all the sugar has been converted to ethanol. But when I look at that, I'm kind of skeptical. I don't know exactly what's going on there. It's some sort of estimate. Why does that seem like that might not be true? Oops, not there. If all my sugar got converted to ethanol, do you really think it would be 1.0? No, it should be something less than that, right? It's mostly water with some ethanol in it, which is less dense. So you'd expect it to go below. And in fact, I have actually had some things where it's gone below, but usually not. And so you can then use charts that assume that this is all of it being converted to ethanol, and you put in your starting amount density, and you assume that all that sugar could be converted, and you look it up on the chart, it tells you what your percent alcohol is. Okay, and the number of estimates that are going into that. Now, what I'm showing in the pictures here this is a hydrometer. So at home, I do not have a 4-place analytical balance. And so it's hard for me to measure density like 1.015 grams per milliliter, but that's about 1.01 or 1.02 is something that most of you would consider to be, it's about the right amount of sweetness, okay, in terms of things. So it's a little bit higher than 1. There's still some sugar left. That's about where most people like that. Now, I have a sweet tooth, and I like things sweeter. But still, this would be hard to measure without an analytical balance. However, we have these things called hydrometers, which are like $10 on Amazon. And what they are is there's a bunch of, it's all sealed in glass, so don't get worried. But there's a lead weight down here that makes it sink. And then it's got air up here. And essentially it sinks to the level such that this gauge, they're calibrated, that this gauge will very accurately tell you the density. Okay, so that's how the hydrometer works. And so if this solution was, let's say it's whatever density is right now, let's say we made it more dense, added sugar to it, this would rise and the gauge would rise. If more of the sugar had been converted to ethanol, it would be less dense, and this would fall in lower, and I'd tick off more marks on that right there. Okay? Very nifty device. Okay, so that's how we can use density, right? Density is important for telling us if we're like checking our brew as we're going, outside of tasting it to see how much sugar is left, which you can do. That's a way to test how far it's going and whether it's still continuing to ferment. All right, so now I'd like to switch from talking really about the ethanol to talking about the carbon dioxide. All right, so we care about the carbon dioxide as well, either because we don't want it or we want it. And so if you don't want it, what you would do is degas your brew. Okay, so there's gonna be carbon dioxide in there. If I pull this right out of my basement or out of my fridge really even, and I decide to pour some off without doing anything else to it, once it's fermented, it's gonna be a little bit sparkly. Okay, it's gonna have some little bubbles in it, and I don't really like that in my wine. So that'd be one reason I might want to degas it, get rid of the bubbles. And then another reason I might want to degas it is because you can get some off flavors sometimes. All right. And one of my first brews, so I started doing this with apple ciders, and I made an apple cider at home. It was the cheapest apple cider I could buy, or apple juice I could buy. I didn't add any sugar to it. It was out of a kit, and it worked really quite well. I was like, wow, this is really pretty good for a first attempt at this, considering what I put into it. So I thought, well, of course I want more alcohol. So I'm going to add more sugar. And so I added more sugar to it. And I actually set up, like, you wait a while for these things. And when you first start brewing, you're really excited, right? Now it's not hard. I can put this in my basement I can have an experiment. I can put it in my basement for a month or two. I can forget about it. I have things in my basement that have been sitting more than a year just because I kind of lost interest. I mean, I'm no longer just chomping at the bit to try this new thing I've made. But then I was like, oh, I want to try a bunch of new things. So I made a bunch of ciders, and I cranked up the sugar in it, and they made these awful hydrogen sulfide things. So stuff that even when I had COVID and couldn't smell anything, I couldn't drink. And so that's something you'd like to degas. That would make it better. Not better enough for those. But if you got a little bit of it, you'd be able to help it. And degassing can remove those things as well. So those are reasons you might want to degas your brew. Okay. So let's think about, if we're going to think about getting the gases out of water, this is a water solution essentially, how might we do that? What we want to do is think about the properties of gases for that. So first off, water is very polar, right? We know that. We know that from Gen Chem at this point. And most gases that are produced or absorbed in brewing are nonpolar. So we'll look at CO2 specifically in a minute, but I think you probably learned in your classes, CO2 is nonpolar, oxygen's nonpolar, nitrogen's nonpolar, and this awful hydrogen sulfide is also nonpolar. And we can explain the polarity of water and gases using electronegativity and molecular shapes. I'm going to spend a little time on this because it's going to be on my class's test in a couple days, and I think it might be on Dr. Anderson's test as well. So let's look at carbon dioxide. Two things to make a molecule polar. What are they? Uh-oh. Has to have polar bonds, right? And we determine whether something has a polar bond based on, this is an electronegativity table, the differences in the electronegativity of the atoms. So carbon dioxide, this is the one we're looking to get rid of. Carbon dioxide has carbon has an electronegativity of 2.5, and oxygen has an electronegativity of 3.5. We subtract the two, we get a difference of 1. That's a really polar bond. Okay, 1 is a very polar bond. So we've got electrons that are being pulled over this direction to the oxygen, and electrons that are being pulled over that direction to the oxygen. Two really polar bonds. Is carbon dioxide polar? No, why not? Because the directions of the polarity of those bonds oppose each other, right? I can't draw a line down the middle of this molecule anywhere that has a positive on one side and a negative on another side, simplistically, right? But that's one way to think about it. I don't have more positive over here than over here, okay? So that's a nonpolar molecule. Okay, so why would I get carbon dioxide in that though, right? I've got a glass of water here I threw out. Let's say that I dumped out, but let's say, we'll just talk about this right here. I just started that. It's not really fermenting yet. Maybe those of you right up here, maybe there's a bubble. I don't think there's even bubbles. But if we were to taste this, there would be no real bubbles that we could detect in there. Why is that? As opposed to something I'd fermented for a long time. Why, when you drink a glass of water, do you not taste carbon dioxide bubbles in it? Well, what's going on there, and why do you have bubbles in something like a soda? What's going on there is that carbon dioxide isn't very soluble in water. But if you put a high pressure of carbon dioxide over water, that will drive it in, okay? And that's Henry's law. We haven't gone over this in Gen Chem yet, but we will. And so the solubility of a gas is determined by some constant that's different for every gas, based on what the pressure is above that gas, or above that liquid, okay? So in other words, the pressure above this matters. So if I have a bottle of brew here that's open to the air, it's going to have 0.00041 atmospheres of carbon dioxide. That's essentially the amount of carbon dioxide in the air, roughly, worldwide. Depends a little bit on season. Okay? So that's how much it is. However, if I'm brewing this and it is fermented for a while, what happens is carbon dioxide is going to fill this space, and I'm going to end up with 1 atmosphere of pressure, which is the pressure we're under right now, in the air above the brew. And so since I have a higher pressure of that carbon dioxide above this, I will get more dissolved in there. Does that make sense? So that is, it will still be less than like when you crack open your soda, right? Anybody know what pressure the top layer is in a can of soda when they pack it? It's 3 atmospheres. So this is 1 atmosphere. For your soda, for it to be as fizzy as it is, they pack it, they seal it with 3 atmospheres. And then when you pop it, what happens right away? Gas starts coming out right away. Okay? It's not staying around under that the new pressure. All right. Now it occurs to me that I forgot to, I may still have this. We're gonna go, and if you've been in one of my classes, you'll see I don't have any hesitancy of going to the internet. So I want to show you a quick video on one method for degassing. And by going to YouTube here, I'm in danger of showing you all the kind of stuff I like to watch. So what we want to do is we want to look at, this is a guy named Charles who does do your own fermentation. We're gonna listen to just a little bit of what Charles has to say here, if my sound is hooked up. Here we go. All right. So Charles is about to show us one way we can degas.
So we're going to get this process started. It's been sanitized already with star sands. I just need to get it in the hole. Sometimes you got to work it in a little bit, but it will fit. And using a trick that I learned from this Amazon site that I got this from, there is a funnel. Since this is really designed for anywhere from 1 to 6 gallon cardboard, using a funnel will pretty much help stop a lot of air from getting down in there or being drawn in there. And using my drill, and this is a 3/8" drill, by the way. So put it and tighten that in, and I'm ready to go. Now, yeah, I mean, if I really wanted to, I could. This is plastic, so I could have just cut it down to size, but. Hey, why do that? This will work just as well. And then from there, you just want to just go ahead and start the agitation. Then you can go back and forth for a couple of seconds. And what you begin to see is a little bit of CO2 is beginning to release. It's displacing what oxygen was in there. And you're going to continue doing this off and on, probably for the next half hour. A few seconds this way, a few seconds that way. Let it come to rest so that.
Okay, and so why I was showing you that, you see if I can read, oh no, that's it. I'm in where I want to be. Why I was showing you that is I'm talking about degassing a brew and getting bubbles out of it, right? But I wanted you to see how much bubbles. You see that was a fair amount? Hopefully, so he was getting a lot of bubbles off the top of that. Okay, so there's a lot of carbon dioxide that ends up in one of these once you put the top layer under 1 atmosphere of pressure. Now, something he said that the oxygen was going to get displaced. Why did he say the oxygen was going to get displaced? And in thinking about that, we can bring another concept that we've been working on in Gen Chem for the next test. So what we have here is we have the density of a gas. And what you'll remember is we can talk about the density of a gas being the molar mass of that gas over the molar volume of that gas. All right, so if we're at 1 standard pressure, or if we're at standard pressure, I should say, depending on how old you are and which standard pressure system they were using. If it's me, a standard volume is 22.4 liters. And carbon dioxide weighs more than oxygen does, or nitrogen. And so what you can see is we'd end up with we take the molar mass of carbon dioxide here, and we get a density of 2 grams per liter, as opposed to a density of 1.4 grams per liter for the oxygen. All right, and oxygen's kind of your enemy if you're doing brewing, especially if you are going to age your wine or whatever it is for a while, because things can oxidize in there and give you flavors you're not after. All right, so what's going to happen is as carbon dioxide is produced in this, it's going to fill the bottom. It's going to sit on the bottom because it's more dense, and the oxygen and the nitrogen, which are the main other components of air, are going to be pushed out. Okay, so they're going to get pushed out first. So right now, they're maybe being pushed out, and here we've got a bubble just about to happen. And you can see that this is going right now. Okay, so that's why you'll end up with a layer. By the time this is done, this will all be carbon dioxide in here. Okay, maybe that's not very exciting. How about death and destruction? So there's something called the Lake Nyos disaster, which is it's a volcanic lake in Africa. And what happens with some of these lakes, this is a rare sort of thing, is but carbon dioxide can be produced in the ground, and it can end up sitting at the bottom of the lake, okay? And then what can happen is you can end up with something happening, like a rock slide can come down, or you can end up with an earthquake, or something that causes that carbon dioxide that's sitting happily at the bottom of the lake to be released. So it kind of, the water turns over, and a bunch of carbon dioxide gets released into the air. Now, the problem with that is that carbon dioxide is heavier than air. So it doesn't get released into the air like that. It fills up, and then it runs down the hill here, and it kills all the cattle. And in this case, it killed 1,700 people as well. In terms of it made a layer of carbon dioxide, and essentially the cattle and the people suffocated because they had no oxygen. So that's another example of carbon dioxide being more dense than air, and might make it stick a little bit better. Okay. Okay. So you can degas your brew by getting it out into regular atmosphere, and then you can disturb it, and the carbon dioxide will come out, kind of like what happened with the lake. All right. Another way to degas your brew is you can heat it. So these gases and water are not very soluble at high temperatures, and they're more soluble at lower temperatures. So if you were to take whatever it was you were brewing and you were to increase the temperature, you would find that the solubility of carbon dioxide in that would go down as you increase the temperature. So if you heat it, you're going to see those carbon dioxide bubbles come out. And that's, in fact, when I make mulled wine from this, it starts bubbling right away. And the bubbling, it's actually carbon dioxide coming out, not it boiling. Okay? So if you don't care about what the heat does to it, and for fine wines, you don't want to heat them, right? Not a fine wine. None of the stuff I make is fine wine. So I don't mind heating it to get the gas to come out. And you notice, did anybody hear how long Charles said he was supposed to work at that? 30 minutes. Yeah, I don't have 30 minutes worth of patience to sit there running the drill back and forth. I actually do have one of those because I had to play with it. So that's another way. So you can heat it. We'll come back to that in a little bit. All right. What if I want more bubbles in it, though? What if I'm making a beer and I want more bubbles than I would get from it fermenting, which you would for the amount of bubbles that are normally in a beer? Well, one of the things you can do is you can get like a keg or a mini keg. This is a mini keg. I bought one of these. I have it in my basement. Not with brewed stuff in it, though. And you can take CO2 cartridges and screw them in there. You put whatever you want to add the bubbles to in here. You put layers of carbon dioxide in there. You throw it in your refrigerator because carbon dioxide dissolves more at lower temperatures. And that can help you get this all carbonated. All right, and how would that work? Well, what you're doing is you're adding carbon dioxide on the top, and you're also adding more carbon dioxide, right? So we think about this right here. I'm going to put this under pressure. We know from our gas laws in general chemistry, right? PV nRT, if I add more N, I get a higher P, right? If I add more carbon dioxide gas up above it, I'm going up above my solution, I'm going to get a higher pressure. And then if I have a higher pressure, I'm going to dissolve more carbon dioxide. All right, so we're using our gas laws again there. Unfortunately for me, these don't. It hasn't worked well. I tried it out 4 times, and twice it was okay, and twice all I would get was foam out, even though I was trying the troubleshooting things they had. So I've given up on that. And what I do now is I naturally carbonate my brews. This is what I did before. I wanted something a little more consistent, but I've had to go back to this. So what you do in this case is you take what's brewing, and before all the sugar is consumed, I could take this and I could cap it, right? I could take this and I could leave the cap on, and it would get more carbonated. But there'll be a problem with that, and I'll show you that in a second. Or if all the sugar had been used, I could add more sugar, and then I could put it in bottles and cap it. All right? And in that case, you're adding your sugar, the yeast go in, the yeast make more carbon dioxide, and that's going to increase your pressure in the top space. And so we think about that right here. We think a lot of yeast make the carbon dioxide, it bubbles up here, the pressure of this goes up, and that makes me keep more carbon dioxide in solution here based on Henry's law. So that's another way to carbonate things, and that's what I do now. But there is a danger with that. If you let this stuff ferment and ferment and ferment, and you've got, these are nice cap bottles, but you just have regular beer bottles are what I use, and you ferment in there, eventually you'll get so much carbon dioxide that the bottle will shatter. And I don't know how well you can see here, but this is a broken bottle sitting in a bucket. So if you do this sort of thing, anybody who's experienced and does this sort of thing, I have like 5-gallon buckets that I put the top on, and I let them carbonate in there in case I forget and mess up with that. Dr. Sarisky, who's my wife, a lot of you know that already, but my wife has been thrilled when I would do this. I'll talk about pasteurization next. When I've done this, and then I've gone to pasteurize and had these blow up on the stove. And she particularly liked it when I was making a cherry wine, or cherry fizz wine, and it blew cherry colored stuff all over the kitchen, including the fume hood, or the oven hood. Okay, so you need to be careful with that natural carbonation. It's not as controllable. And so you want to get, it's always a dance between, you want enough bubbles, but not too many. So let's say you let something ferment till it's done, right? What you can do is you can then sweeten something afterwards, and that's when you might hear dry or sweet. So if somebody says, oh, this is dry, what they mean is it's not very sweet. I always, before I started doing this, I never knew what that, dry martini, what is that? Dry martini is something that's not sweet. So you can add various sorts of things to sweeten that. We've got a whole bunch of different examples here. If you add something to sweeten it that is fermentable, like regular sugar, okay, your yeast are going to ferment that, and they're going to make bubbles, and you need to worry about blowing your container up, and you have to be worried about getting bubbles if you care about those as well. What you could do instead is you could add some of these artificial sweeteners, and yeast won't be able to do anything with that. It'll make it sweeter, but they won't be able to make carbon dioxide with that. So you wouldn't need to worry about it. You'd be done. Also, I'd like to do hard ciders. And a fun thing to do with that is you could just take a can of apple juice, concentrate, and after you've made your cider, it's alcoholic, you dump this in to sweeten it. And you kind of get the same mixing of flavors there. Okay. Let's talk about, so we've got these dangers, we've got stuff fermenting, we want to stop it fermenting. Even when I make like my mojito wine and it's done, I'm nervous about just putting it in a bottle, right? It's done, it's still sweet. I'm worried about putting it in a bottle, putting it in my basement, and then it's going to get going again, even though I didn't realize it. And I'm going to have broken bottles in the basement. So one of the ways you can stop fermentation, maybe you've heard about this, you can use Camden tablets. And essentially, what those are is they contain potassium or sodium metabisulfite. So here's your formula for that. Okay, I've given this talk before. I brought this up and I was like, oh, why do I have a wiki page with all this stuff on it? And then I started reading it, and I went, oh yeah, now I remember. So let's talk about some things. So you can use these to stop your wine from fermenting, okay? And it's often used in wine. You can also use it as, let's see, there's some really good ones in here. You can use it in tint etching iron-based metal samples for microstructural analysis. Oh, that's great. And you could use it in photography. What other ones are good here? You can use it to remove tree stumps. There's a lot of neat uses for Campton tablets, or sodium meta, not Campton tablets so much, but sodium metabisulfate. And I kind of don't want that in my wine. I'd rather not have that in what I'm drinking. Doesn't mean that I don't drink wine that has it in it if it's made by somebody else. So what I like to do is I like to do pasteurization. All right, so Louis Pasteur came up with this. Well, he didn't come up with it. He was the one who got credit for it, at least in the Western world, even though it's been known in China since the early 12th century. And what it involves in terms of at least this sort of brewing is you heat up to about 145 degrees Fahrenheit for 15 minutes, and that's going to kill yeast and other microorganisms. And so then after I do that, so if I was going to want to bottle this and leave it in my basement for a while, I would do this heat treatment. I would put it in a sterilized bottle. I would cap it. I'd put it in my basement. I wouldn't worry about it starting up again. It also has the benefit, for me, what I do is I heat them and I have them uncapped. So I fill bottles, I have the cap's not screwed down. And then because carbon dioxide is less soluble at higher temperatures, like 145 degrees Fahrenheit, the bubbles come out. And so that's my lazy man's way of getting the bubbles out of my brew without having to mix it a whole bunch. Okay, this brings up one other thing that I thought was fun. I learned this before I learned about pasteurizing things. But I used to teach a cooking course. I think maybe next year I may be teaching a cooking course again. And when I was reading on that, so you get like a cast iron pan. What are you supposed to do with a cast iron pan? Season it, right? So you season it, you get an oil coating on it so that it doesn't rust, essentially. But also, what about washing it because of the seasoning? You never use soap on it. And in fact, they often just say, hey, you're just supposed to wipe it out and put it back away, right? You're not even supposed to really wash it with water. And it turns out, like with the pasteurization, if you get something to, I don't know what the temperature is in Fahrenheit, but if you get something to 70 degrees Celsius, you're essentially going to kill any microorganisms in it. All right. So if you have a frying pan and you put it on the stove, how hot is that getting? Is it getting hotter than the boiling point of water? What do you think? Boiling point of water is 100 degrees Celsius. So you get this, whenever you cook with one of these on the stove, you kill anything that's in it. All right. So when my wife and my daughter go out of town, I don't wash anything. Right? I have a cast iron pan, but there's no reason to wash that either. Or wash this. Because if you're worried about getting sick from something, you're going to kill it. If I put coffee in my mug that I haven't washed in about 2 weeks, it's going to kill anything that was in there. Same sort of thing with that pan and that. So the only reason to wash something, in my opinion, is if you don't like the flavor that was there the last time. Okay? So if you always cook with onions and garlic, you don't need to wash that. Okay, I think that's it. There's a lot more chemistry involved in brewing, including a lot more complex stuff than we talked about today. But that's where I'm going to stop. I know it's late at night and late in the semester, and you guys want to get out of here, and I've almost gone for an hour anyway. So I'll take questions, and I'll understand if you can. Oh, yeah.
What's your favorite thing that you made?
What's my favorite thing that I made? It's the mojito wine. So it's mint and lime rinds and sugar. Yes.
Are you gonna start brewing club up here? We did it.
Yes, I know. So I will start brewing club up if there's enough student interest. Okay, you guys feel free to head out. If anybody else has questions. If you have questions, feel free to come down.